Hi everyone, in this video we'll be discussing the problem water the plants. Previously this problem has been asked in Microsoft. So let us quickly read the problem statement and see what the problem says, and then we will try to decompose this problem. So basically the problem says that there is a gallery with plants divided into n parts. So basically there is a gallery and there are n parts that are there in this gallery, and the parts are numbered from 0 to n minus 1. There are provisions for attaching water sprinklers in every division. So in every division that is there is a water sprinkler. A sprinkler with a range x at the division I can water all the plants from I minus 1 to I plus 1. So basically what does this mean? Suppose that at the ith position there is a sprinkler. Okay, suppose that what happens is at the ith position, let's say I value is 5. At the ith position there is a sprinkler okay, at this place. Then suppose that for this sprinkler the capacity is, let's say 3. Okay, then in that case, if this is having the value as 3, then you can say that it can water the plants from here till I plus x, that is till point number 8. Okay, and it can also point from minus I minus x also. So I minus x is what? 5 minus 3 would be nothing but 2. So basically if the ith position is 5 and the range of this sprinkler, the ith sprinkler is 3, then it can water plants from 2 to the range 8. 2 is the minimum because that is I minus x, that is 5 minus 3 is 2, and then you can see 5 plus 3 is 8. So that is why it can water from 2 to 8. So that is how you can understand that we can get the range for each and every sprinkler. Okay, if we are at the ith sprinkler, if we are at the ith position, so its capacity would be given in A of I, that is you can say x, right? Now after that it says that in this array, that is gallery array, so basically for the ith index or the ith division that I am at, its whatever is range, its range is whatever its x value is, that will be indicated by gallery of I. Okay, and then what you can do is, if you want the leftmost range, then that will be I minus gallery of I, and the right would be I plus gallery of I. Okay, that will be the overall total leftmost and rightmost range for a particular sprinkler. Now it also says that if suppose that a particular value, suppose that gallery of I is what? If it is minus 1, so this means that there is no sprinkler attached and it does not have any capacity. So you have to return the minimum number of sprinklers that you need to turn on. Okay, so basically this problem is kind of greedy in nature because it says that if there will be a lot of sprinklers, so you need to tell what is the minimum number of sprinklers that we need such that we can water all the divisions. Okay, such that need to be turned on to water the entire gallery. And you can understand that the gallery has n parts starting from 0 till n minus 1. So the starting point is 0 and ending point is n minus 1. If there is no possible way, then you have to return minus 1. Otherwise you have to return the minimum number of sprinklers. So let us quickly see this example here. So let's say we have been given the test case where we have been given what? Where we have been given n as 6, and as I said, this problem is very popular because it has been previously asked in companies like Microsoft. Okay, so basically n is given as 6, and let's say we have been given what? Minus 1 2 2 and then minus 1 0 0. So let's say we have been given what? Minus 1 2 2 and then we have minus 1 and then 0 and 0. Okay, and suppose in terms of indexing what we are having is, if this is I, so this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. So here for the 0th index, if you will observe, right, so the gallery, in the gallery array, what is the scenario? In the gallery array you can see value is minus 1, so this means at the 0th place there is no sprinkler. Then at this index number 1 you have a sprinkler, and this sprinkler is starting from where? This sprinkler is at the 1th index and it is having a range of 2. So basically what will be the left range? It will be nothing but, you can say the index, that is 1 minus 2. So the leftmost range would be minus 2 for it, and the right range would be how much? The right range would be what? 1 plus 2, that is 3. So this is the range. Then after that if you will see for the next sprinkler, so the left range would be what? It would be 2 minus 2, that is 0, and the right range would be what? 2 plus 2, that is I plus this value x, that is 2, so that would be 4. Then after that if you will see, so next sprinkler at index 3, there is no sprinkler because it is minus 1. Then the next value is 0, so you can say that the range will be from what? 4 to 4 only, I guess, right? And then nextly also the value is 0, so the range will be from 5 to 5 only, right? So these are the sprinklers that are given. Now once I have the capacity of the sprinklers, right, so I can store all this in a list. Okay, I can store all the sprinkler in a list. Okay, let's say what I will do is minus 1 comma 3, then the next sprinkler is 0 comma 4, is having the range 0 comma 4, then 4 4, and then 5, 5, right? You can see that in this situation, the way that we were given the test case, you can observe that in this case, the range of the sprinklers is coming out in ascending order. But suppose if the range of the sprinkler is not coming out in the ascending order, right? So in that case, what you need to do is you need to sort according to the starting point, okay? Like, because for every sprinkler, there is a leftmost range and the rightmost range. So you will sort the sprinkler pair, okay? You will sort the pair of this sprinkler list, and what you will do basically is you will sort them according to the first parameter, that is according to the leftmost range of the sprinkler, because you want to start from the left side. So that is why you'll start checking from the left. And when you'll sort, so that will take how much time? Obviously, if there are n pairs in the worst case, so it would take n log n time. Now if you sort these pairs, so obviously it will be like -1, 3 will be coming first, then you will have 0, 4, then you will have what? You will have 4, 4, and then after that you will have what? You will have 5, 5 here. Okay, this is what you are going to have. Once you have the pairs, then you will be starting off, okay? And you will also keep a track of the count, that how many sprinklers would you be requiring, okay? So now once this part is done, so let us say that what we have is, let's say we have a number line here. So the n value was how much? I guess the n value was 6. So let me do the indexing from 0 to 5 here. Okay, so let's say this is point number 0, then this is point 1, then this is 2, then this is 3, this is 4, and this is 5, right? Now there's a sprinkler which has the range as what? From -1. So let's say from -1 till 3. There's a sprinkler which has this much range. Then there is another sprinkler which has the range from 0 to 4, okay? And then there's a sprinkler from 4 to 4, and there is a sprinkler from 5 to 5. So notice that we have to, ultimately what we have to make sure is that since the n value was 6 and the divisions would be from 0 till n-1, so we have to make sure that every division gets water, okay? So 0, 1, 2, 3, 4, 5, everything should be covered overall, right? Now if you will see, so I will start from the very first sprinkler, guys, okay? So initially I'll say that my counter would be what? My counter of the number of sprinklers I would mark as 0. Okay, so let us say this. So initially I'll mark my count of the sprinklers as nothing but 0, and then after that what I will do is I'll come to this sprinkler, right? The very first starting sprinkler. And when I come to the very starting sprinkler, that is when I'm coming to this ith sprinkler, right, then I will check. So also I will check my target position. So initially my target would be what? Initially my target would be to color 0, okay, because I want to color which like I want to water which particular division. I want to water the 0th place, okay? So then I will check. What will I check? I will check that is the starting point of the ith sprinkler that I am at, is it less than or equal to the target position? Yes, you can see that -1 is less than equal to the target position, that is 0. Okay, because -1 is the starting point of the ith sprinkler, and I have the value of the division as 0. So I can say that yes, we can basically water it. Then I will say that if I can water this, so then it is possible to water this division, that is fine. But now I will check that if there are several overlapping in this range, if there are several overlapping sprinklers, then in that case I will choose the one which is having the maximum higher range. So you can see that in this range, you can see that this is the ith guy. Then I will check for the I plus 1th guy. Does the I plus 1th element exist? Yes, the I plus 1th element does exist, and the I plus 1th element is what? 0, 4. Now I will check. So what I am checking here is I'm checking that does the next sprinkler that is there, that is the I plus 1th sprinkler, does it overlap? Yes, the I plus 1th sprinkler does overlap. If the I plus 1th sprinkler does overlap, then I will say that if the current sprinkler that I am at, if it is having the ending range as 3, so the maximum range that I updated was 3, okay, because of this sprinkler, because of using this sprinkler. But since this one is also overlapping at certain ranges, so I'll say that out of 3 and 4, which one I should choose? I should choose the maximum, that is 4. Okay, so then you can basically see here that in this particular test case, I'll just show you the run. Okay, so you can see that basically the sprinkler at the index 2 that is there, right? So the sprinkler that is there at the index 2, let me just show you quickly. So basically the sprinkler that is there at the index 2, its starting point is what? Its starting point is less than equal to the target, that is 0. okay, and then it has a higher range. Okay, so then I will say that instead of that I will consider this one. So I'll say that okay, the maximum range is 4, so I'll consider 4. And now because of this sprinkler, this whole part will get from 0 till 4, all the division will get water. Okay, now after that, since this is my maximum range, so the maximum is 4, then next time the target range would be what? The target range would be nothing but maximum plus 1. So what is maximum plus 1 here? Maximum plus 1 would be 5. So now my target is that I want to do what? I want to color or I want to water the 5th index. So then I will go to the next sprinkler, and the next sprinkler is having starting less, but it is ending earlier. Since because of that case I cannot give the water to the 5th index. Okay, then what I will do is I'll go to the next index. So I'll go to this next pair, and I can see that it overlaps with the current target. So then I will say that yes, I'll use it. And then after that there is no I plus 1th element, so I can say that I have colored all the sprinklers, because like I have colored all the divisions with the help of 2 sprinklers, because you can see that I will count 2 sprinklers only. Why? Because one sprinkler was when I counted here, right? Because if they were overlapping, so I'll choose the one which is having larger range. So this one I can choose, right? And then after that I can choose 5,5. So because of 2 sprinklers I am able to color the or I'm able to water the whole divisions, all the divisions. Okay, so that is what we can do. And if suppose that what happens if suppose that still there are several divisions left and my sprinklers got over, if the range of the sprinklers is over, if the sprinkler array list is over, then this would mean that I cannot color them completely. So for that I will return -1, that it is impossible. Also one more thing, that one case, as I already discussed, that it might happen that the sprinklers might end. Okay, or like what might happen is that if the sprinklers are there, right? If there are sprinklers with you, so the first case is that sprinklers might end for you, and then after that you cannot water all the divisions, right? And also one more thing you need to keep a track of, that suppose that if you are at a particular sprinkler, right, and suppose that the target is 6, but your current sprinkler that you are at, it is going to give the water from 7th or 8th position, then you cannot water the 6th position. So in that case also, if there is any sprinkler whose starting point is greater than the target division, then also you have to return -1, that you cannot color that middle division. Okay, so that is how you need to focus. Now let's try and quickly implement this in terms of code as well, so that will be more clear. And obviously it's a bit greedy, the thought process of this question is greedy in nature, and we have to just use sorting. So now what I will do is I'll simply say that first of all we need to declare a vector or a list of pairs in which we'll have int comma int, and let's name it as v. And then after this what we will do is we'll simply iterate. So we'll iterate through the gallery array. So int I starts from what? 0. Then we will say I is less than n, then we'll do an I plus plus. Now after this is done, then what we will do here is we'll say that if it happens that the gallery that is there, okay, gallery that is there, if the gallery of I is greater than -1, so if it is not equal to -1, if it has a range, then we have to update. So then we will say that inside the sprinkler we will push back what? We'll push back the starting point as what? I minus gallery of I. Then the end point would be what? I plus gallery of I. Okay, because if I is the point, then the leftmost index would be I minus x and the right would be I plus x, as I've already discussed in the very starting of the dry run. Okay, then once this is done, then I have stored all the sprinklers that are switched on. But now I want to start from the beginning, so my target would be starting from beginning. That is one thing, and I also need to keep a track of the counter. So initially I'll mark the count as 0, and also I need to sort the sprinkler array. Why? Because I'll be starting from the very starting division, that is 0. So that is why I want the sprinklers range to be in ascending order. Okay, that is based on starting point. Okay, then we'll do v dot end here. So we'll sort this sprinkler array, and then it will get sorted according to the first parameter. Once that is done, then what is our job now? So we have the target, okay, and we have the counter as well. Now once we have this, then we will say that we will iterate until when? So we'll say that while the target is less than n. Okay, so till that point of time we'll iterate while the target division is lesser than n. So if we have not reached the last division, so last division is n-1 until the time we have reached the last division. So once we cross that, then only we should stop. Right now, once that is done, so we need to focus on what? Once that is done, then we will simply say that initially we need to have the ith sprinkler also. So we'll say that I will be the index indicating the current ith sprinkler that we are at. Okay, now what we want to do is we will check the condition that suppose that if I is equal to v dot size. So if if we have exhausted all the sprinklers. Suppose we still had a target division, but we have exhausted all the sprinklers. This means that with the given sprinklers, with all the sprinklers that is we have, it is not possible to give water to all the divisions. Then I should return -1. And another case could be that suppose that the ith sprinkler that I am at, if its starting is greater than my target position. So suppose that I wanted to water the 6th position, but the current sprinkler that I am at, it is saying that it will water from 8th position. So in that case, I can say that I want to water from 8th position, but the requirement was for 6th. So I cannot do that. If I cannot do it for any division, then I should say that it is impossible and I should return -1 for that case. Okay. Otherwise, what I need to do is I need to say that if like I will check for the overlapping. So okay. So starting from I-1 until the time I-1 is less than n, and we have the overlapping sprinklers. So for them, we will iterate and we'll consider the maximum range. Okay. So initially we'll say that the rightmost maximum range would be what? It would be the range of the ith sprinkler, that is v of I dot second. We'll update, and then after that we'll say that if the I+1th sprinkler does exist. Okay. If it does exist, and what happens is if the I+1th sprinklers, if its starting point is less than equal to the target. So if the starting point of the ith sprinkler is less than equal to the division, then we can say that it is going to overlap, its starting is going to overlap. Then in such a case, which sprinkler will choose? If for this current position that I'm at, if there are several sprinklers that are starting from this position or they are starting before, then I'll say that I'll choose only one sprinkler, but I'll choose the one which is having a larger writer range. Okay, because if I choose the one which is having higher write range, then I will have to choose less and less sprinklers only. Okay, then I will say that okay, simply what we need to do is we need to do I++, and we'll say that maximum will be equal to max of max comma what we can say it as v of I+1 dot second. So we'll update it with the second. So whichever, if couple of sprinklers are there that can water the current division, then in that case we will choose only one sprinkler, but we'll choose the one which has the higher writer range, so that we have to choose lesser and least number of sprinklers for watering. Okay, then after that we'll say that we'll increase our count of the sprinklers. So what we can do is we can increase the count of the sprinklers after that, and then once this is done, then we need to say that since the sprinkler that is there, its maximum capacity is mx, right? So it must have watered from the position till mx, whatever was the range, it must have watered till that point. Now after that, I want the next target would be if the range of the current sprinkler is till 4th point. So the next point or the next division that I want to give water to is the mx plus 1th position. So I'll say that now the target would be mx plus 1 after this. Okay, and then after this is done, then I also should increase the value of I, because since the work of the ith sprinkler is done, then after that I'll move to the I+1th sprinkler. Okay, and then at the end of the day, we can simply return what? We can simply return the counter here. So that can tell us about how many sprinklers we are using. Now let us try and quickly compile this code to see if we have made any mistakes. Obviously you can see that we are taking order of n time in the worst case, because what I'm doing here is I am storing sprinklers inside a list of list, in which case they can be n different sprinklers, and also the time complexity would be n log n. Let's see what is the error that we are getting. So it says that and is the error. So let's check. It says less than equal to. So v of I, yeah, I should say v of I dot first is less than equal to. Okay, because if there is a I+1 sprinkler whose starting is at equal to the target or less than, then I should. You can see it is working fine for the samples. Let's try and submit this to check if the code is getting accepted or not. If it will not, then we'll check, but I hope it should. Okay, so it is not working for the sample test case. I might have made a mistake somewhere. So let me just quickly iterate through the code and let's check it. So what I have done here is I basically have firstly I have declared a pair. Okay, so in this pair what I've done is I have the int comma int, then I am iterating for all the sprinklers, and if there is any ith sprinkler whose value is greater than -1, then I'm considering what? I minus gallery of I and I plus gallery of I as a pair, and then after that we are sorting the sprinkler. Okay, then initially I mark my target as 0 and count as 0 and I as 0 as well. Then until the target is reached, till that point of time we are less than n. Okay, then I can say that what I've done is if it happens that I reach the last sprinkler. Okay, if the current sprinkler that I am at, if its starting point is greater than the target, then in such a case I need to return -1. Otherwise my maximum range would be what? the ith sprinkler dot second. Okay, then what I've done is while the I plus 1 is less than n, so okay, I should not do less than n, sorry. Actually n is not the number of sprinklers. Now I should do v dot size, because the number of sprinklers is actually dependent on v dot size and not on it is dependent on v dot size. Okay, because I, that is indicating for the sprinkler, so it might happen that there are not n sprinklers now, because some sprinklers are -1, right? So there does not exist some sprinklers at some places. Now I will like to submit this and let's check whether it is working fine or not. Okay, still it is giving one error, so I will check this back again. So what I've done is I plus 1 being lesser than this, then what I've done is, if the ith sprinkler that I am at, if it is less than equal to target, then I'm increasing my I, and then maximum is max of this thing and v of I dot second. Okay, I made a mistake. I should have written v of I dot second, because if the I plus 1 sprinkler is inside the range, then I would have updated it like this. Okay, then after that we increase the count and then we make the target as mx plus 1, then I plus plus. Yeah, now let's try and submit. So I made a basic mistake here. Let's check this up. Okay, let's try and submit it again. Okay, so now our code is working. Yes, you can see that our code was able to pass all the test cases. So this was the mistake that a small mistake that I made, okay, in the second while condition that I was writing here. In case if you have any doubts, so you can ask those doubts in the comments, and this problem has been asked in Microsoft. So make sure to submit this problem on your own as well and try to code it up once you have understood the logic. And thank you for watching this video. Make sure to comment understood if you have completely understood, and take care guys.